In 2003, the average age of a mother at the time of her first childbirth was 25.2. To determine if the average age has increased, a random sample of 1,200 mothers is taken and is found to have a sample mean age of 25.5 with a standard deviation of 4.8. Determine whether the mean age has increased using a significance level of alpha equals 0.05. First, let's write down all the given information. We have that the mean age of the first childbirth is 25.2, and this is mu naught. We have that the sample size is 1,200, so n equals 1,200. We have that the sample mean is 25.5, which is x bar. And we have the sample standard deviation, which is s. In order to answer the question, we need to perform a hypothesis test on the population mean. First, we need to check the following conditions. First, we have to check that the sample is obtained using simple random sampling. The sample is stated to be random, so this condition is satisfied. Now we have to check that the sample has no outliers and the population from which the sample is drawn is normally distributed, or the sample size is large, which is greater than or equal to 30. The sample size is 1,200, which is greater than or equal to 30, so this condition is satisfied. Now we have to check that the sampled values are independent of each other, or that the sample size is less than or equal to 5% of the population size. 1,200 is much less than 5% of the population size, so this condition is satisfied. Now we can go to step 2, which is to write the null and alternative hypothesis. First, let's write the null hypothesis H naught. The question is asking about the mean age, so the null hypothesis will contain mu. And the null hypothesis always has equals, and it is equal to the population mean, or mu naught, which is 25.2. Now let's write the alternative hypothesis. The alternative hypothesis will also involve mu, and the question is asking if the mean age has increased. So we will use greater than. And we always use the same number as in the null hypothesis, which is 25.2. Now let's determine what type of test this is. Because the alternative hypothesis contains greater than, this is a right-tailed test. Now let's determine the significance level, or alpha. We are told that alpha equals 0.05. In step 4, we can either use the p-value approach or the classical approach. First, we will use the p-value approach. First, we need to compute the p-value. Let's go to StatCrunch to compute the p-value. Let's go to Stat, tstats, one sample with summary. Let's type the sample mean, which is 25.5. Now let's type the sample standard deviation, which is 4.8. Now let's type the sample size, which is 1,200. We are performing a hypothesis test, so we will select this option here. And we have that mu equals 25.2. And the alternative hypothesis is mu is greater than 25.2. Now let's press compute. And we get the t-statistic here and the p-value here. We get that the p-value is approximately 0.0153. Now let's compare the p-value to alpha. We have that 0.0153 is less than 0.05. So the p-value is less than alpha. So because the p-value is less than alpha, we reject H naught. And now we write our conclusion. There is sufficient evidence at the 0.05 significance level to conclude that the mean age of a mother at the time of her first childbirth is greater than 25.2. Now let's use the classical approach. We can start the classical approach with step 4. First, we have to compute the test statistic T naught. You can also compute the test statistic in StatCrunch. Let's substitute the values into the formula. Type this in your calculator and we get approximately 2.17. Now let's draw a sketch. This is a right-tailed test with alpha equals 0.05, so that means the area in the right tail will be 0.05. Now let's find the critical value on table 7. We have that the area in the right tail is 0.05, and the degrees of freedom is 1 less than the sample size. So the degrees of freedom is 1,199. We will use the numbers in the bottom row. And the corresponding critical value is 1.645. And that value goes here. Now let's plot the test statistic T0. Recall that T0 is approximately 2.17, and T0 goes here. Notice that T0 is in the rejection region. So we reject H0. Now let's state our conclusion. There is sufficient evidence at the 0.05 significance level to conclude that the mean age of a mother at the time of her first childbirth is greater than 25.2.